Hello, this video will be on Euclid's division. That is a very useful statement in elementary number theory, and it says something about a pair of natural numbers. I will use this shortcut, this notation for the set of all natural numbers dispelled n. So let's assume that the first in the pair is not smaller than the second. Then the Euclid's division says that the first, the larger, can be written as a multiple of the second plus perhaps something, some leftover, something which is less than the second. So the statement says that for any a and b, there are some q which counts how many copies of b fits inside a and r. And moreover, this q and r will be unique. So that is the complete statement. That is the main point of this little video. In mathematics, everything is to be proved, but some things have, which means that some things are explained in terms of other things which are presumably easier. So in this case, the easier thing will be the so-called well-ordering principle. Or axiom rather. So this well-ordering axiom will say that any subset of the set of natural numbers has the smallest element. I'm not going to prove it using this well-ordering axiom. I would rather delegate it to you. Just to give a hint, let's look at the geometry of the situation. So let's put our natural numbers on number line. So here somewhere we have this 0 point, and then we have the number b, and then we have somewhere here number a. And then we really use b as a measuring stick and measure how many copies of b we can fit inside a. So 3 copies still in, 4, 5, I extended my real line, but 6 will be somewhere here. So 6 will be larger, but 5 will still be smaller, so 5 is the largest number of copies. The division statement for this pair will be 5 copies of b plus some remainder, which is this distance. So if all the points are integer points, then r will also be a natural number. And the well-ordering principle would work if you find an interesting subset, interesting in the way that the smallest element will be telling you something about your story. And here is the smallest element. So I would suggest looking at, say, this is like in here, multiples of b, but looking at those multiples which are to the right of a. And then the smallest will be this one. It's not what you want this one, but the step from the first to the right and the last to the left is easy. So that's as much hint as I wanted to give about proving. Let me finish this short video with a concrete example. So let me do this Euclid division for a pair of numbers. Let me start with the smaller, say 1, 2, 3, and the bigger will be, say, 5, 6, and 7. So then I have to write 5, 6, and 7 as some number of copies of 1, 2, 3, and then some remainder. So how many copies will fit the maximal number of copies? Of 5 is too many, 4. 4 will be the right number, so if we take 4 copies of 1, 2, 3, we will have 480, and then plus 12, so that will be 92. 492 taken out of 567 will leave us with 5 is going to be the last digit, and then 16 without 9 will give us 7. So in this example, q is equal to 4 and r is equal to 75. That's it for now. See you later.